Do you know an empty string is not actually empty in C programming? Are you comfortable with character arrays, array pointers, strings and string pointers? Come, let's see these things in detail in this video. Welcome to our YouTube channel Command Line, where you will learn intricate details and core concepts of Linux and system programming. Today we are going to learn some fundamental concepts of strings and some interview questions based on those concepts. This topic is very important for interview preparation because 20 to 30% of technical interview questions will be based on strings. These concepts are same for both C and C++. The data center market is growing at the rate of 22% per year. There is already a huge demand for Linux system programmers all over the world. Consider subscribing to our channel if you really want to become an expert in that area. In this video, we are going to see these 5 topics. First, what are strings and how they are stored in the memory. Strings are not a basic data type in C. Then, how can you declare and use a string variable? Second, how string library functions are working. There is a string library comes with C programming which makes programmers' life much easier by providing multiple utility functions. We will see how these functions are working and what they rely upon. Third, we will see the difference between size of and strlen. The size of operator in C and C++ works differently for strings. We will explore that in this topic. Fourth, string literals. What are string literals and how they differ from normal strings? At last, we will see a weird string initialization method. As I told you earlier, string is not a fundamental data type in C. C programming has only character, integer, floating point and double as its fundamental data types. The closest data type for a string is character. So a character in C programming is constructed as a sequence of characters ending with a null byte. For example, if I want to store the string Linux, it will be like this. Null is nothing but value 0. It is represented with null macro or 0 escaped with backslash. Always remember that null is a single character. That's why it is surrounded with a single quotes. As null requires 1 byte, a string takes length of the string plus 1 byte for its storage. Important point to remember here is for a string, the last byte should be always null because as we are going to see next, many interview questions are based on this. Let's see some interview questions based on the null termination byte. How many bytes required to store the string C programming? C space programming is 13 characters, so they require 13 bytes. As you know, all strings need to end with a null byte, additional 1 byte is added. So total 14 bytes required to store the string C programming. Next question. How many bytes of memory is allocated by this statement int s equal to empty string? Though it is an empty string, a string should always terminate with a null byte. Thus, 1 byte of memory is allocated by this expression. Next, we will see the library function strlen. It calculates the length of a string. It starts from the first address and counts every byte until it sees a null. While calculating the length, it doesn't include the null byte. For this example, strlen starts counting from the first character C and it keeps going until it sees a null after the character G. As strlen doesn't include the null character, it will provide 13 as the output. This function is provided by the string library. This string library provides multiple other functions like strcat, strc2a, etc. All these functions rely on the fact that a string will always end with a null. You can use these functions in your program by including the header file string.h. This is one of a frequently asked question in technical interviews. What is the output of this code? The header file stdio is included for printf and string.h is included for strlen. The first line, character str of 12 equal to string abcdef allocates 12 bytes memory and stores the character from A to F inside it. As a string should be always terminated with null, the byte after F is filled with a null. Next, str of 3 equals to null. This line updates 4th byte of the character array, so D is replaced with a null. Then, this printf is printing the length of the string. The length calculation starts from A and goes until it reaches a null byte. As 4th byte is null, it prints the length of the string as 3. Learning from this example is, though there are characters after null, strlen doesn't count them. Let's execute the code and verify. This is a little tricky problem. We need a symbol table to solve it. Let's say this machine has 48 bytes of memory addressed from 0 to 47. The first line in main allocates 5 bytes and stores hello into it. Let's say address 0 is allocated for this variable. A symbol table entry is created and the string hello is stored in the address 0. As we need additional 1 byte for null, total 6 bytes are required. C program will not care about how many bytes are allocated, it simply writes the string hello with a null byte from the address 0. The second line creates a new character array str1 and stores the word world in that. In the symbol table, the last allocation was from address 0 to next 5 bytes, so C finds address 5 is free. Though null byte from the previous allocation is already written at the location, C program doesn't care about it. So a new symbol table entry is created and the string is stored in the memory. The third line prints the length of the string variable str. As strlen calculates the length by starting from the first byte and continues till it encounters a null, it starts from address 0 and keeps counting till address 10, where it sees a null for the first time. Though the variable str is only 5 bytes long, strlen will print 11 as the length of the string. Let's compile this code and execute. When it comes to strings, most people get confused with sizeof and strlen. Sizeof gives the memory allocated for a variable, whereas strlen counts the character till it finds a null. Sizeof is not actually a function. It is sometimes called as sizeof operator. If it's not a function, how does it work? It gets its data from the symbol table. As symbol table is created during compilation time itself, the sizeof operator can even work before the program starts execution. Thus, you can call sizeof from some debugging tools even before the code execution starts. On the other hand, strlen is a function. As it counts the number of characters in the memory, strlen requires the memory to be allocated before its invocation. So strlen works only during program execution. Let's try to understand the concept with an example program. Consider this program and tell me what is the output of this code. The first line of the program creates 10-byte character array and stores the string hello in it. 10 bytes of memory is allocated. A symbol table entry is created for the variable str and stores the string in the memory location. Next line prints strlen and sizeof of the variable str. As we know, strlen starts from the byte 0 and counts until it finds a null byte. It will return 5. The sizeof operator looks at the symbol table under the type column for the variable str. It is a character array of 10 elements. As size of a character is 1 byte, 10 elements require 10 bytes. So the sizeof operator will return 10. So far in all of our examples, we have seen only character arrays. But in C, strings can be handled with a string pointer as well. Though string pointers and character arrays function similarly, they are different. Consider the C program using both character array and a string pointer. As we already know, for the first statement, 10 bytes of memory will be allocated, a symbol table entry will be created, and the string hello will be stored in it. The second statement creates a character pointer. As any pointer in C requires 4 bytes of memory, 4 bytes of memory is allocated, and a symbol table entry is created. In that location, the address of the variable str is stored. Here you should remember, an array's variable name always represents its address. We will see that concept in detail in another video. The next line prints both str and ptr-str strings. As both represents value 0, printf prints the string from the address 0 until it reaches a null byte. So the output will be hello space hello. The crucial part of the program is this line. Here we are indexing the pointer. One thing you should understand here is an array without indexing will act like a pointer. Similarly, a pointer with indexing is an array. Thus, this printf will print E and E. I will leave this program as an exercise for you to try. From the understanding we got in the previous slide, let's try to find what will be the output of this code. We have learned that a pointer with indexing will act like an array. So ptr-str of 1 is representing the letter E and it will be replaced with the character A. Thus the output should be HALLO. Let's verify our prediction by executing the code. But against our expectation, we got the program crashed. What would be the issue? To understand it, we should follow the regular process we usually do. Let's have the memory and the symbol table as usual. The first line of the code creates a character pointer and stores the address of the string hello in it. Let's allocate memory for the pointer and add an entry in the symbol table. Now save the address of the string in the allocated memory. But what is the address of the string hello? Where it is stored in the memory? In the last program, we had a character array that stored the string, but now the string is directly assigned to the pointer. There are no variables associated with the string. So then what will be the address? In this case, the C program allocates a memory to store the string, but as no variables are associated, the memory is marked as read-only. This memory is allocated in a section called text section. So the string is called as string constant or a string literal. If you are unaware of what a text section is, please watch the video in the description to learn more about memory segmentation. Thus, in the second line, when you try to overwrite the string, it actually tries to edit the memory which is marked as read-only, which is not allowed. Thus, the program crashes with a segmentation fault. This is a very common question asked in technical interviews. The last topic we are going to see in this video is concatenation of string literals. It is a simple one. Let's take this statement. At first, it may look like a statement with syntax error, but surprisingly, it works in C. You can assign two string literals like this to an array. It will actually allocate necessary memory and copy the value in it. Again, this is one of the commonly asked interview questions. Thank you for watching this video. Please consider subscribing to our channel to learn more about C programming, Linux, and system programming. All the best with your technical journey. We will meet in next video.